Okay, complex number sheet. Very easy. It's not going to take me long to go through this, but I'll try to do it carefully. We figured out how to do negatives inside radicals. Finally, whenever you see that negative, just take it out into the front as an I, and then do the square root just like you did before. That negative is not there anymore. I removed it, and now it's an I. Square root of 9, though, is 3. Now remember, this is a product, right? This is all multiplication. There's an invisible dot there. You don't see a plus here. The mistake I see is that people do this. They put like plus 3. But, there's no plus here and there's no plus here. If you don't see a plus anywhere, you can't decide to just put one there. This is all multiplication. 3 times 7 is 21. And the I goes along for the ride. Remember, this is a complex number. We don't write I-21. We write 21I. All right? You put the number first and then the I. Same thing here. Take that negative, move it out in the front as an I. You just put it after the 3. So now you have 28. But I know that I can break 28 down with 4 and 7, right? We've done this before. So split it up. Remember, this is all multiplication. I'm going to put the dots there to be really clear. 4 comes out of jail. It's a perfect square. So it's 2, right? Square root of 4 is 2. Don't do anything cute. Just take it right out of jail. Now you're going to hook up the 2 and the 3 and make a 6. I goes along for the ride. What about the radical 7? It also goes along for the ride. Can't ditch it. It's there. So very simple. Just take the negatives out. Just break the radicals down. Nothing complicated. All right, problems 3 and 4. 3 requires quite a bit more work than the other ones. You have to break down the radicals first. Then you're going to add them to get, see, now here there's a plus. So I'm going to take the negatives and pull them in the front. Do that first. So you get I, radical 75, plus I, radical 27. Now that they're positive, I can break them down. So 75, I'm going to break down with 25 and 3. Why? Because 25 is a perfect square. I need to take it out of jail. 27, you don't have much of a choice there, right? I mean, 9 and 3. 25 comes out of jail. It's 5. Hook it up with the I. Get 5I. Radical 3. Make my I more prominent. The 3 comes out to jail. Hooks up with the I. You get 3I. 3I what? Radical 3. They're both imaginary numbers. How do you know? They have I's. They both have the same radical part. So, you can combine them. If you had 5I radical 3's and you had 3 more, now you have 8 of them. So you just add the numbers in front. I goes along for the ride, and so does the radical 3. You can't ditch that. Now, I know this was a weird thing to do, the powers of the I. And I told you the key was to write it with 4s, because I to the 4th power is 1. So you want to split up 11. Remember, you add powers. So you want to break up the 11. Let's see, 4 plus 4 is 8. 8 plus 3 is 11. So, right, 4, 4, 3. That makes 11. But I to the 4th was 1. Right? This is all multiplication. I to the 4th is 1. What's I to the 3rd? That's negative I. So 1 times negative I is negative I. Remember, there's only 4 things it can be. It can be a 1. It can be a negative 1. It can be an I or a negative I. Those are the only 4 things you can get, and they repeat. If I had given you I to the 12th, I already know what this is. This is divisible by 4, right? It's I4, I4, I4. So that's 1. So it's not that hard, and don't freak out if you can't do this, really. I did it because it was in the woodwork. Okay, problem 5. I'm going to do 2 more after this. I'm going to do a bonus one. The one that I had wanted you to do in class, I just forgot to ask you. So you multiply these two. Now, again, the instinct might be, to take out the calculator and multiply negative 49 by negative 81, but multiplication inside the radicals is not defined if the numbers are negative. You have no choice but to take these negatives out as your I. You have to remove them, or the problem's going to be wrong if you don't do this. You cannot multiply them together. Now, I don't expect you to do 49 times 81. Why? Because these are perfect squares. Take them out of jail. There's no reason to multiply those numbers together. So 49 comes out of jail as 7. 81 comes out of jail as 9, right? And hook it up with the I. Now multiply them together. 7 and 9 make 63. This is the important part. It's the whole problem. I times I is I squared. Now, you can't leave the shit like that. You know what I squared is. I told it to you. I gave you the definition of it. I squared is -1. So you have to replace it with -1. So 63 times -1 is -63. You know, like the one I did in class, I did with 4 and 9. And I said to you, you know, if you just do -4 and -9 and multiply them, you're like, oh, negative times negative is positive. Oh, you get a positive, it's 6. It's wrong. This doesn't work. I showed you in class this doesn't work. You can't do this. Negatives are not defined inside the radical, so you cannot multiply them together. This multiplication is undefined, so that won't work. You must do what I did here, which is take the negatives out first as I. You always get an I squared though, so you got to make sure to replace it. So this answer will always be negative. You will not get the right thing. You get a different thing if you don't do that. So I know this question is on your test. That's why I'm making extra sure to do it. And I'm really emphasizing what to do right. All right, the bonus problems. I mean, 14 is a bonus problem. You did 12. This problem is a joke, but I put it on your test anyway. Gonna give you something easy to do. These are complex numbers, right? A plus bi, a real part and imaginary part. Very simple. Distribute the minus sign, right? -8, right? -1 times 8. And then -1 times -9 is positive 9i. Drop your parentheses now because you don't need it anymore. And then, real simple, add or subtract the real parts and then the imaginary parts. I have a 3 take away 8, that's -5. That's the real part. The imaginary part, you have 9 imaginary friends and you lose 2. Oh no, I only have 7 imaginary friends left. Or as I like to say in class, 7 idiots, right? 9i, take away 2i, 7i. It's a friggin' joke, that question. You cannot possibly get that wrong, all right? I mean, unless you switch the signs wrong. But that question is a gift. I mean, give me a break. You're just combining numbers together. It's really easy. There's nothing to do. You have real part, imaginary part. Try to write it in the correct form, right? A plus bi. Will I deduct points if you don't? No, but you're supposed to. You're not supposed to write, you know, this is backwards. I'm not going to mark it wrong, but, you know, please try to put it in the proper form. Now, this one I do also have on your exam. I want to make sure you can do the baby multiplication. It's very easy. Just distribute one at a time. 3 times -3 is -9. What about the I? It goes along for the ride. Now at the end, I have a 3 times -8. That's -24. Now be careful. I times I makes I squared. Don't stop there, right? We know what I squared is. I squared is -1. I just did it on the other question. So replace the I squared with a -1. And now, haha, negative and negative make positive 24. And remember, A plus BI, put this after it. You do want to write it in the proper form, right? A plus BI. This is what a complex number is. A real part and an imaginary part. The real part is supposed to go first. You have to put the plus 24? No. But I'm putting it for emphasis. All right, so that was the bonus one. I meant to have you do that one. I just forgot. And whatever. All right, so those are questions you will see on the exam based on the complex numbers. Nothing too nuts, except for that I thing. I'm not going to ask you to do powers of I. It's stupid. All right. The rest of this stuff, all fair game.